Hey everyone, we're just going to wait a little bit longer so everyone can join us. You're doing well. Okay, people are coming in. Welcome, welcome. Want some more folks in. So welcome everybody. Thanks for joining. I'm going to wait a little bit longer before we get started. Just let people come in. All right. Welcome to everyone around the world. It's nice to see you here. Okay, I think we're going to go ahead and get started. I just want to say welcome everybody. My name is Michelle Greer and you're here for a webinar about HCP Packer. Hopefully you read the blog post. We did go GA with HCP Packer just a few weeks ago. If you're not familiar, HCP Packer provides build automation and compliance for Terraform workflows. So now to just logistics, this webinar is being recorded and the recording will be made available to you after post-processing. That usually takes about a week. If you have questions, please remember to type your questions in the question box and we will answer them during our Q&A session. And so with that, let's go ahead and jump in. So I'm Michelle Greer. I'm a Senior Product Marketing Manager here at HashiCorp. I will be joined by Amar Loyo, who is a Solutions Engineer. We are so happy to see you here. So what prompted us to create HCP Packer and Packer in general? So updating images, as you may know, is often a siloed and manual process, particularly across clouds. I've been at HashiCorp for a while. I can't say I've ever heard any practitioner say, you know what, I'm going to work. I really want to update our company's images. It's just not something that people particularly love to do, especially manually. So Packer, I'm sure many of you already use Packer. It's kind of quietly dominated the industry when it comes to image management. It provides one workflow for managing images across clouds. And so what are some of the things that make Packer so popular? One, it's easy to read and write. You may have saw last year, it went through a major rewrite and now leverages HCL2, which makes it easy if you don't use it already and you're a Terraform practitioner, because it'll look very familiar to you. It's extensible. So Packer really is the only way to create images across clouds and integrate with other configuration tools. And of course, Packer is open source. So you can leverage existing community templates or write your own. And that includes builders as well. So What are some of the core Packer features? One of the ones you'll probably be the most familiar with are builders. They're responsible for generating images for various clouds and on-prem infrastructure as well. Provisioners prepare the system for using built-in and third-party software to install and configure the image. You have post-processors which run the image, run after the image is built and upload artifacts and more. And then pay attention to this. Packer also enables data sources, which allow data from outside of Packer to be fetched to use in configurations. And that includes data from HCP Packer. And so you're going to see how this works here in a bit. Packer enables codification, and codification is the foundation for standardization and automation, right? This is what we all want rather than updating images manually. So say you're using Packer today, there's still some decisions that your organization needs to make, right? First of all, you need to decide what are the golden images and what version should they use, right? Different teams, different people may have different iterations of a specific image that they want to use. You'll need to define what is the ideal workflow to ensure images are hard and secure and compliant. One way people do this often is in terms of managing what is the ideal image is they use a spreadsheet. That's not really ideal. But you also need to determine, can this process be replicated across clouds, right? What is our workflow for managing these images? And also, can that process be integrated into current provisioning workflows? Ideally, you're not using all sorts of different tools. You want to get in flow, you want to work with the infrastructure that you already have. And so you want to have a consistent provisioning workflow. So this is where HCP Packer comes in. So HCP Packer is a multi-cloud image registry. To note, it is not Packer in the cloud. We are not storing images. So note that. It uses metadata from your existing images to track iterations and build artifacts across downstream builds and provisioning pipelines. And it makes this data available via an API and an interface. And so this forms the foundation of a multi-cloud golden image pipeline. And that's what we're going to show you here in a bit. HCP Packer bridges the gap between image factories and image deployments. You can gain visibility into a golden image's downstream builds and associated provisioning pipelines, so no more spreadsheets. You can automate updates by triggering a build or an apply, and you can create a compliant workflow for images across all of your infrastructure. And you'll also see that. So you change a golden image once, and you can update it across downstream builds, very appealing. And you can automate image updates across provisioning pipelines. And so this screen, you'll notice you have HCP Packer. It integrates with Terraform Cloud using a feature called Run Tasks. If you're not familiar with Run Tasks, please check that out in the documentation and on our blog. You'll see how this integration works today. So very exciting stuff to see. So with that, I'm going to turn things over to Omar, and he's going to show you. He has a recorded demo. This will kind of cut down on some of the build times and whatnot, and you can see how this works.
Cool, great. Thank you, Michelle. So let me share my screen. Can you see it, actually?
Yes.
Hey everyone. Thank you very much, Michelle, for the brief introduction. Today, or first, I will talk about the technical HCP Packer features before I introduce you to my demo. So let's start. First of all, you have to understand, and I'm sure you know, it is difficult to manage life cycles of VMs in an enterprise environment because there are so many of them and they have to update them regularly due to security patches or some changes in application code. Packer is a great solution to build images, but because it's such a great solution, it is hard to find your way within the forest of images that are generated in your environment. And HCP Packer helps practitioners to manage the libraries of images that are built in their company. So HCP Packer is not Packer in the cloud as the other tools we have as a managed option. It is a multi-cloud registry that tracks images across clouds. It is not a solution to build images. So again, Packer is a solution to build identical images for all these environments. HCP Packer is a solution that gathers the metadata of all the images that has been built with Packer, whether on local machines, on VM, or on AWS, GCP, or Azure. So once you have built your image with Packer, you will receive some informations about it. Who has deployed an image? You will get informations about the desired platform. So let's say this image is located on AWS, Azure, or GCP. What kind of instance types do you have? And you will get a versioning of your images in your bucket, so-called iterations, and they will get some numbers of it. So that's a versioning of those iterations. And if you want more details about your iterations or about your images, you can even find out the cloud image ID from the specific cloud provider. So let's say in AWS, you will get the Amazon machine image ID as well. And all these informations are stored in our so-called buckets. And these buckets are created once when you define that in your Packer template. So when you start to describe your virtual machine or your Docker image with Packer, you will have one HCP registry block where you define your bucket name, put some descriptions on it, and build your resource, your image in that case. What I will show you in my demo after that. With the help of channel declarations, codifying images becomes so easy and enables you to standardize golden images and use them across teams. You can create new projects by using the most current golden image, start creating new environments for test dev, development, or user acceptance tests before you push it to production. Another example of HCP Packer is the use of channels that security and platform teams can update base images and use channels to point to the latest iteration. And when the teams rebuild the images, Packer will automatically retrieve the channel's iteration and rebuild with the new updated base image. So what is an iteration? Every time Packer builds a template or a golden image, it creates an immutable record of the build called an image iteration. An iteration can have images associated with it, and each iteration has a unique identifier that maps to the Git SHA that happens on every Git commit of your repository. So it makes it pretty simple to locate those images, let's say the iterations, and use them throughout your whole deployment or infrastructure deployment pipeline. The beauty of HCP Packer here is that when you present that through an API, you can easily implement Packer images into Terraform with a simple block of code. So that is really filling a gap, which was really important, because so far all the people who are doing CI/CD, who are generating images with Packer, had to build their own stuff with bash scripts or home build solutions to connect somehow Packer with Terraform to call the latest images. So far it was difficult to do so, and now it is available out of the box. You just have to install the Packer binary, define the HCP Packer registry, of course having some secrets, and then you're good to go. And what you only need to do is define your data source and add the HCP Packer provider plugin in your config, and that's it. So you don't have to copy and pasting image IDs into your Terraform code anymore. And now it is quite easy to connect both solutions through a repository with HCP. What are the prerequisites to use HCP Packer in your workflow or in your Terraform code? Of course, when you start to create your template with Packer, you definitely should download the latest Packer version or update the update your actual or your current Packer version, of course. Having HCP Packer secrets as environmental variables, or put them in a secrets management solutions like, for example, Vault. And I recommend to define your code in HCL, because most of the functions like labeling buckets, build images, labeling images are not supported with JSON as far as I know. And all the new features they will come up, they will be supported for HCL first. So in that case, make sure you learn HCL. It's pretty simple to use. If you're already familiar with Terraform, HCL is the language to go with Packer as well. With our Terraform integration, we have seen in the slide before, Terraform will refer to a channel, and it doesn't need to know of the multiple Packer iterations behind the scene. It just needs to know which channel it can deploy from. So Terraform will find the AMI ID by looking up an interaction so Terraform will find the AMI ID by looking up an interaction based on the name of the channel. And with the HCP provider block, it is simple to reuse images across your infrastructure pipelines in your whole Terraform code, same as you would declare AWS providers or your resource blocks. And it will reduce manual tasks of hard coding image IDs by codifying images instead in your Terraform code, which leads to, of course, less human error by fetching obsolete images. And while everything is codified, all HCP Packer users can use this new feature now to revoke images when an image is outdated, or if there is a vulnerability and you're making sure that users do not deploy obsolete images, as I said. So each time when you fetch an image ID from HCP Packer, you will get a feedback in your deployment with Terraform to make sure that your image is not compromised or outdated. So we will see this in the demo where Terraform will say in a run task, this image is okay, this one is tracked by the HCP Packer workflow, or this one is a hard copied image ID outside of the workflow, so please use the latest iteration. That's what we're gonna see in the demo later on. And you only have to configure, as I said, Terraform run task with the HCP Packer application integration that validates your data source and scans your Terraform resources for references to HCP Packer iteration or HCP Packer image data sources. So when it detects a reference data resource, it will automatically warn you if it retrieves a revoked image iteration or an image iteration that is scheduled for revocation. So as I said, that makes it really easy to use HCP Packer in your whole deployment process, because you don't have to copy and pasting AMI IDs, and with that you codify everything, you can even go a step further and integrate some compliance checks, so making sure that these images are really using the HCP Packer iteration ID and not hard copied AMIs, for example. And yeah, this feature is for all HCP Packer users with a plus tier licensing. So first, the run tasks will check your Terraform code for hard-coded machine image IDs and checks if images are tracked by HCP Packer. Additionally, it prompts users to use the HCP Packer data sources to better track and manage machine images. And this helps organizations to track the image lifecycle in HCP Packer and fetch image IDs from image channels with Terraform code and stay compliant, or making sure you do not use images with some security issues or vulnerabilities in your application code. Okay, so that's it. That's all the technical features. I will introduce you to my demo, how the workflow is implemented in my case, and after that we are going to check all the new features, revoking images, or let's say iterations, and check how we can implement the compliance checks with the help of Terraform Cloud Run tasks. So that's me. I have a Visual Studio Code running for my code. In my code, I defined a Packer template where I'm gonna commit some changes and push it into my GitHub repository. Once I've done that, my actions YAML file will be triggered with a GitHub actions. So it will trigger a Packer build. So Packer will start to build the image, but before that, it's going to initialize my secrets. It's going to validate if the Packer template is okay, if there are any syntax errors, making sure the code is okay, and then it starts to deploy or to create the AMI, the Amazon Machine Image. And when it's done that, when Packer has done that, Packer will create an artifact in AWS, and HCP Packer will go out and collect all the metadata through the API. And my second workflow will be where I trigger a deployment run in Terraform Cloud. You can do that via API, CLI, of course. In my case, it's a version control system based workflow. So I will trigger a run, then Terraform will go out there, fetch the latest image ID from HCP Packer, as we codified our images in our code. And you will see that you don't have to copy anymore image IDs from the specific cloud provider. It then creates the infrastructure. So magic happens. After that, we should see a website seeing how we can create a golden image pipeline, hopefully. So let's jump into the demo. First of all, I'm going to show you my code. In that case, that's my Packer template. I have my Amazon plugin here, some variables, define my region. I'm then looking for an Ubuntu image in Amazon AWS, where I will create some temporary credentials for SSH into it and doing some building things for the image. In that case, I will call for an Ubuntu image 2104 suit, because we have already one image out there in HCP Packer, which is outdated and not secure anymore. That's Ubuntu 1604. So we'll make sure that we're gonna use this new one. And then we have our build block here. We can name it as webinar here. We are looking for the source that we defined before here in our source block. And then I have a HCP Packer registry, and that is really key, because here I'm defining my bucket name. I can put some descriptions on it. I can even label or tag my buckets here. And of course I can tag or label all my image builds that are in my bucket as well. So I can then say, okay, put some labels here for operating system, Ubuntu Hirsuit, and the version 2104. So it makes it easier for me to find the right image after that. And then I have a provisioner block. Once the image, the EC2 instance is up and running, it will do some install scripts as the install steps, and after that we should be able to reach to our HTTP web service. We have a provisioner file where we copy our source, our index file from source to the host there. So before I'm gonna build my image, let's jump into HCP Packer. So first of all, before you start with HCP Packer, you have to log into the HashiCorp cloud platform. In there you will see some, there's a dashboard, a cloud dashboard with some products here, so you can start deploying a Vault instance, for example, or a Consul cluster as well. In our case, we will create a Packer registry. So when you start with HCP Packer, of course, there is no bucket defined here. So in that case, you always have to define that in your code. So as we have seen before, because it's not available that we create manually a bucket here. We have to do that by code. That's totally okay. Before we do so, we have to make sure that we have our secrets available. Where can I find those secrets? You have to go to the access control, then check for your user. Okay, that's me. Then I go to the service principals, and then I can start to create a new service principal, like here, like saying webinar, giving him a role. An admin role, of course, can invite others and other users and edit roles for those users, and then save it. And then I'm good to go for generating my secrets. So that's my HCP client ID, and that is my HCP client secret. Of course, you have to put those secrets in Terraform Cloud as well, so the Terraform deployment is able to communicate to HCP Packer in order to fetch the latest image ID from the iterations. So, of course, I did all the pre-work here. That's just a demo with my private account. So when we check HCP Packer here, we can see that we already have a bucket inside. So in that case, it's named Apache, as we have seen in our config, and we already have 1 iterations inside. When we check our bucket, we can see our description with what we defined earlier in our code. I can see the platform and I can see my labels inside. And then I can go to iterations, and I only have 1 version from my iterations, and that's this one here. I can check now for some labels, some descriptions here. I can see, oh, this image is hosted or it's located on AWS. I have my build labels here. That's the operating system, Ubuntu Xenia, and the version 16.04. So we'll make sure that we update this version, of course, and map the iteration, the new version of these iterations to the desired channel. So let's go back to the Packer code. So make sure that we commit those changes. Or first we have to add this things git commit Ubuntu 21.04 git push. Good. Now we should see that our image building is running. So let me check that. Refresh quickly. Iterations. Now there you go. It looks good. Okay. So it says, of course, incomplete because the building, the image build is running. We can see our fingerprint from the git commit. It's also stored here. So let's check our repository in GitHub. So I created our action YAML, of course. So when we check actions, we can then see our workflow running, our CI workflow for the golden image. Okay, so it set up the job. It starts to build our Docker container. I will check out from the repository, configure our credentials, validate the template if it's good. Syntax checks is okay. Everything looks good. And now it will take a while. When the image is created. Okay, this looks good. Our build was successful, so let's check again. Going down there, we can see that our AMI was created. We can see the AMI, the Amazon Machine Image ID, located in Frankfurt. And then you can see that after we have created our image, all the metadata was published to our HCP registry on the Packer Apache with the iterations and the fingerprint here. So let's check again our bucket here. Now we have 2 iterations, and there's version 2 with our desired fingerprint from the Git commit. Really cool. So what we can see here, our labels we have set in our code. So in that case, our operating system Ubuntu Here Suite and the version 2104, and there is our image we have seen before in our action template. So of course I then can say, let's make sure that this image is pointing to the desired channel, in that case production, because the current one here is outdated and not secure anymore. So we then have to go to the channels tab, change the assigned iteration to version 2 and update it. And all we have to do now is to deploy our code in Terraform Cloud, and it will fetch the most current image here. But before we do so, let's check our Terraform code. I have my provider, the AWS, of course, with the desired region. I have my HCP provider plugin as well, enabled to commit that Terraform can communicate with the HCP registry, some resources for networking, and let's go to the data source block. So as you can see here in the data source block, we are defining our HCP Packer iteration with a bucket name and a channel, and of course a data source where our image is actually located. In that case, it's in AWS in EU Central 1, and it will call this information down under in the resource code block, where we define our AWS instance named Apache. So we will call our data source here for the as we defined our AMI. So it will look after the specific provider in the desired region and looking for the defined bucket and defined channel. So when we check our variables here, we can see that we have our variables bucket as default Apache and our channel default production. Of course, if you have several workspaces or working with different environments, let's say for production, test dev, Q&A, or user acceptance tests, you can of course change those variables in Terraform Cloud, as they here only the default ones. So that's all, that's it. So you don't have to, as I said, to copy your image IDs and paste it in your Terraform code. You only have to define these resources in your code. So then I put some outputs here for our web service pointing to the public IP, so we can make sure that we can reach out to our web server. So we can then put some outputs here for my image ID for looking after the AMI, and of course the most current fingerprint version that's pointing to the latest iterations that is pointed to a channel, of course, and then we can check our output for the active image out there. So that actually that image that we are using for deployment. So let's jump into our Terraform workspace. As you can see here, that's my Terraform workspace and mapped to our repository. So we can see our runs, states, and variables, of course. Down here I have my sensitive variables marked as environmentals. And of course you have to define the HCP client secret and the client ID as well. And there you can see my local variables, channel and bucket I defined here. And now I can start to start a new plan run. So Terraform will go out there and fetch the most current image ID from the iterations, from the desired channel. As you can see here, some resources will be created, of course, and there's a planned output as well. After our successful apply, we can then reach out to our web service. There's also a cost estimation, gives a brief overview of how much would it cost the compute instance, and then you just confirm by this run. This looks good. Our apply was successful. All our resources are created. We can check our outputs. We can see our public IP address, reachable from the outside world. We can see our Amazon machine image ID. That's the one which was collected by HCP Packer as well, where we can find it in our bucket. So in our iteration, of course, we can see the fingerprint of our active image and of course the fingerprint from the Ubuntu version. So let's check our web service. This looks good. And click on the hyperlinks and go through the documentation as well. So that's one example how you can use iterations and point them to channels in order to use them in your Terraform code for an easy deployment process. It actually shows as well how you can separate the duties from people and organizations who are responsible for building images in a CI or CD procedure, and then the other teams or projects who can then use those images in the deployment process, in the infrastructure as code deployment process. Okay, so let's talk about introducing, or let's say integrating, some compliance checks in our whole deployment process, making sure that we do not use some outdated images or using some hard-coded AMIs in our deployment process. So I mentioned earlier in my presentation that we can implement some Terraform Cloud Run tasks. So let's go to our settings here and let's do so. So let's check the run tasks here. And as you can see here, I already configured a run tasks, but let's quickly delete this. Oh, I can see here, that's really cool, because before you integrate or if you want to delete an integration, it checks if one of your workspaces are mapped to this run tasks. So I can then say, okay, this run tasks, let's delete this. That was too quick. Let's remove this. Yes, please. And then go to settings again, run tasks, edit this. And now we are able to delete the run tasks. Okay. So before we integrate our HCP Packer application here, we have to check the create run tasks tab here. Name it, of course, HCP Packer. Copy our endpoint URL. That's the information we can find in our bucket in HCP Packer. So you can see here on the top right, integrate with Terraform Cloud, then you will get all the informations for copying and pasting it into Terraform. Then I have my secrets, of course, I need them, or it's actually optional, you don't have to paste them in, but we will do so. And now we create our run tasks. That's great. So back to our workspaces, we're going to choose our workspace Terraform here, going into settings, run tasks, and we can see we have already an available run tasks here. Click on that. We're going to we have the option to choose our enforcement level between advisory. That means that the run will never interrupt if there's an outdated image, or let's say if an image is on a revocation list on the mandatory side, it will fail if one of our images is on a revocation list, that are pointed to a channel, of course, that we're using as a data source. So let's create that one here. That looks good. Now let's go back to HCP Packer, go into our bucket, check our iterations, and now we're gonna set our iteration where we used that as a data source in the Terraform code, and set them on revocation. In that case, we're gonna say, okay, at 11:40 this will be revoked. So now I can then start our run, start a new plan. In that case, Terraform will notify us whether the iteration is on our revocation list for a future date, or if the deployment run is fast enough, it will then say, hey, at 11:40 this image or this iteration is already on a revocation, please use another one. And it will also check if there is another iteration and not map to a channel, which then says, okay, please map our most current iteration here to a channel, so that Terraform is able to fetch that data. In our case, the task has failed, of course, because it says that the resources that are scanned, the HCP iteration ID and the HCP image ID, was using a revoked image. And yeah, as I said, there is no newer version found in our repository, so we have to check then our iterations and making sure that we reassign a new image to a channel. So we go back to our bucket, and we can then see that we don't have any new images, of course, that we can then assign to a channel. So in our case, we'll say, hey, please restore this iteration, and making it available again. But we're gonna make one more thing. We're gonna say, hey, this image will not be active at 11:50, for example. Put them on revocation again. Start a new plan. Okay, the task has passed. Looks good, but it says this one image we are using, it's good to go, we can deploy the infrastructure, but this one is scheduled to be revoked in future. So let's say if there is a team or someone who's responsible for the CI process of creating images on a weekly or on a monthly basis, the deployment team can then see, okay, that's our image on a revocation list, so we will make sure that we are using the most current one. And it's a really cool feature, I would say, because we can then make sure that our infrastructure is compliant, that we don't have any security vulnerabilities in case if there is an update for our application code, or when we have an Ubuntu version or a Windows version which has some security patches available and they're not installed and updated, for that we are using here in our process. So that's it with our compliance checks. That was my demo, of course, and let's go back to our presentation. So why does this all matter? As I said, security matters, but standardization leads to automation with the help of infrastructure as code tools. Let's say, for example, here Terraform and Packer, in a workflow-driven process. And of course, this will lead to saving costs and time in the long run. And not only talking about costs, it lowers, as I said, the chance of human error if I codifying my image build, and I don't have any config spreads when everything is defined in code. And of course, it will improve my security operating system patching during the image creation allows me better security and the ability to keep up with the latest patches, of course. And my deployment time for Terraform will be greatly reduced by using images that are already built, tested, and of course secured. So that's the demo again, the overview. And one more thing, of course, if you're thinking about using some kind of secrets management, there's Vault out there. So there's also a solution, or there's also an option where you can put all these secrets like HCP Packer, client IDs, client secrets into Vault, and GitHub Action can then fetch those secrets and start deploying or triggering the build run with Packer. And of course, it's also capable to create dynamic credentials for the desired cloud provider. Here are some helpful resources from my side. So if you're not familiar with Packer, please go out there, learn Packer now. It's really easy. It's really easy and really convenient. There's a helpful link of how you can use HCP Packer in production. Basically, a much more detailed process of introducing a golden image pipeline, and of course, how you can secure your whole CI/CD pipeline. In that case, with GitHub Actions in conjunction with Vault, and how you can configure an OpenID Connect in Vault for GitHub Action as well.
Thank you so much, Amar, for that great demo. Before we turn it back over to Michelle to lead our live Q&A, we just wanted to take a minute to engage with you, our wonderful audience. Thank you guys so much for joining us today. So we're going to push a quick poll. It's less than a minute. And we just ask that you take a quick read and give us your feedback. We greatly appreciate it. And just in case you don't have the opportunity to respond prior to the Q&A, the same survey will be available at the end of the webinar, so you can give your feedback then. Just super appreciate you guys for joining and responding to the poll. And now we can move forward to Q&A, but we'll take just a hot second to launch the poll and respond. Thank you, guys.
Okay, thanks for attending. Please answer our survey. It really helps us figure out if the products we are building are useful to you. So, you know, this is why we create this stuff. So let me go ahead and get these questions up. Groovy. Thank you. Let's see. So a lot of folks had questions. Does Packer work with on-prem Hyper-V and VMware? There's some also folks asking, does this work with Azure? Packer works with any cloud. Currently, I know we have builders for AWS, Azure, VMware, even Linode and some of those other folks. I think there's even OpenStack. Check out the documentation. If there's a cloud that you want to use or infrastructure that you'd like to use and you don't see builders in our documentation, remember Packer's open source, so that you are more than welcome to create your own builders to manage images anywhere. Okay, so another question on one of the slides, this is for Amar, on one of the slides, it was specified as Chef and Puppet as third-party software to configure images. What about Ansible? Is it still available to be used?
Yes, of course. I already answered this question, I think. And yeah, between the alternative approach would be definitely use Ansible as well. And I always recommend to my customers, if they're working with Packer and creating images, and if the images become more complex, always use some configuration management tool.
Cool. So yeah, I'm going to ask some of the questions that were in the Q&A just because not everybody saw the answers.
Sure,
so, yeah. So when HCP Packer says we can manage 10 images, does that mean 10 iterations of one image or 10 separate images with multiple iterations? And the answer to that is you can manage 10 separate images with multiple iterations. So, you know, bear that in mind. If you create 100 iterations of Ubuntu, you're going to get, that's one image of that same image. So let's see. Okay. does this work with, this is for Amar, does this work with GitHub, or can we set this up with AWS Code Pipeline, GitLab, or Jenkins?
Yes, of course you can. It was just an example of GitHub Actions. You can use Circle CI as well. You can use Jenkins, GitLab CI CD. So they're all possible to do so.
Great. So does this work? I'll answer this. Does this work with Terraform Enterprise? So in order to set up the compliance checks, it does depend on run tasks, which are not currently available in Terraform Enterprise. That being said, we aim to always have parity, and that is on the horizon for sure. It's already being asked for. If you are interested in that, I can connect you to the product manager. Email me at mgreer@hashicorp.com, and I'm happy to connect you. We're always looking for good feedback for some of those customers. Okay, let's see. Some of these questions have already been answered. Okay, I'll answer this too. Do you need to subscribe to HCP Packer registry service for the image meta to be available via Terraform Open Source? So yes, essentially Terraform can manage anything with an API, including HCP products, and so it is essentially leveraging that API to pull the data into Terraform open source configurations. Now, that being said, another question that came up is, can you use HCP Packer or Terraform open source? You can, using that same provider, but if you use Terraform open source with some of your own custom scaffolding, you lose access to the compliance checks, because that depends on run tasks, which is obviously not a Terraform open source feature. So let's see. This is for Amar. Where is the source code for this demo?
I think I shared my source code for this demo on the GitHub. It's basically lomar92/HCP Packer TFSC demo. I can post it on the chat so everyone can catch it up.
Great, thank you. Okay, this is a good question. I'll ask this for Amar. Just to clarify, compliance checks were referred to. In terms of these checks, are these just to ensure that a compliant image is being used, not actually checking the image for compliance, correct?
Can you say that again? Sorry.
Yeah, so to clarify, compliance checks were referred to. In terms of these checks, these are just to ensure that a compliant image is being used, not actually checking the image for compliance. Is that correct?
That is correct. Yeah, it's checking that you actually using the latest image, which you then, so let's say you have a team out there who's responsible for updating those images, making sure that they don't face any security vulnerabilities, and pointing to the desired channel. So if you, in case, say, I'm consuming, or let's say I'm fetching an image which is on revocation list because there's a security vulnerability, Terraform will then notify you with the help of the run task that, hey, this image is on revocation, or let's say this image is not compliant anymore because obviously it's on revocation. Then it will say, hey, check out this new latest iteration in your bucket and make sure that you point to the desired channel. But it will not make sure that the image, as the image it is, that is compliant.
Okay, and Amar, you may not know this. There's been some questions about actually doing compliant, like checking an image for compliance. Have you heard of any customers using third-party tools with Packer open source for that? And if not, I figured I'd ask. I've heard of customers doing this, but you may have seen more.
Unfortunately, in my case, I have not experienced customers using third-party solutions with that. I experienced that some of the customers were integrating partner solutions with the run tasks in case of code scanning with Sneak, for example, or Bridge Crew for more sophisticated cost estimation after the plan run.
Great. So this has come up a few times. Is there an API for changing the channel to a new image iteration, or do you have to do that manually?
Good question. I had the same question as well when I was playing around with HCP Packer. Actually, there's an extensive API doc on our homepage. You can check it out. Of course, you can create your own automatic ways of consuming APIs of HCP as well. And yeah, in that case, if you want to assign your iteration, you have to do it manually, but you can do so as well with APIs, of course.
Great. So we've mentioned that HCP Packer is not Packer in the cloud. Where is the AMI stored typically?
Depends what you're going to define as your provider. Is it AWS? It's going to store the created image on AWS, of course. And HCP Packer goes out there and fetches all the, or collects all the metadata from these images. So making sure that if you have a collection of images, that you find these images really fast. And as well, you can create one Packer template and define several provider plugins, let's say for Azure, for AWS, and create those images for these environments.
Okay, so I'll answer this. This has been asked for several times. People are curious if HCP Packer is going to have an on-prem version. And the answer is not that I'm aware of. But fortunately, because we are not storing your images, we are just storing metadata about your images. So far, and I've been on some calls with some very security and compliance oriented companies, it's not an issue because it's just metadata about your images. It's not the images themselves. And so this has helped them kind of clear some security and compliance hurdles. So, I mean, I suppose if we get enough customer demand and we're making enough money for this, we might entertain that idea. But to my understanding, like there is no plans for that. So let's see. This is maybe a question you can answer, Amar. Is Sentinel integration supported with Packer? If somebody wanted to use Sentinel with HCP Packer, could they?
Good question. From that time now, it's, how do you say it in English? It's not directly integrated. I mean, the integration with the run task is that you don't have to figure out or creating your own Sentinel policies and doing the compliance checks. So it takes the heavy lifting of creating those Sentinel. But I can come back to this question and check with the Packer team because I'm not sure in that case.
Yeah, I haven't heard anything that, I suppose if people want it, we would do it, but I haven't heard anything to that tune. So if you're currently using Terraform Cloud and want to integrate it with Packer, are there any defined steps to migrate to HashiCorp Cloud? There's no need. The two products work together. You don't have to migrate anything. So some of these are kind of repeat questions, and so that's why I'm scanning. That doesn't apply. Will there be a Packer associate exam? I suppose eventually, yeah. Like we're definitely starting to ramp up some of our educational materials. Please stay tuned, and I will pass that on to the education team as a request. Okay. Is there a way users can subscribe to or get notifications when an image is going to be revoked other than a pipeline trigger? Soon. Just stay tuned. That's all I'm going to say. So I think we're right at time. So I want to really thank you guys. Thank everybody for coming. Thank y'all. Me being from Texas, y'all is such a helpful word for coming to our webinar. We really appreciate all your questions, your interest. I'm going to encourage you, please sign up and use it. You get 10 free images for life. We're not going to charge you. So go to cloud.hashicorp.com, sign up. There's some really great tutorials that'll walk you through some of the stuff that you've seen today. Just a reminder, this video will be available to you and sent to you in about a week's time. So we appreciate your patience there, but I guess, yeah, thanks so much. Have a look at the documentation, the Learn Guides. And if you have questions, let us know. Have a great rest of your day, everybody.